I'm going to start with something that still continues to amaze me, which is the DuckDB adoption. And I want to highlight a few things on this list. I mean, it's the usual sort of, oh my God, oh my God, oh my God. But one thing that really shocked me was the 5 million of extension installs for DuckDB that we now have per month. So in case you're not aware, there's some functionality for DuckDB that is bundled as a plugin, as an extension. And we have made this kind of 2024 way of dealing with extensions where you can, from within DuckDB, say, I want this extension, and it downloads it from the internet. Little did we know that this would create a ginormous Amazon bill, because we are now running at something like 2 terabytes a day of extension downloads, which is also a number I didn't know was a thing. We are just very grateful to Cloudflare to not charge us for the traffic. Also, something that is totally wild is the number of visitors to our website. I think we accidentally made one of the more popular websites in this country. We now have like 500,000 unique web visitors, and these are not including the people that install extensions. Those are different. These are just people that go to the website, you know, to look at the documentation, look at our wonderful blog posts, things like that. So that's really crazy. Like these you know, to see these effects that, again, from our limited worldview, based on issue tracker, we wouldn't think would be possible. Also, something I want to highlight today is that there is this DB engines ranking that, you know, people spend a lot of time on, in my opinion, spend too much time on. But we are also quite surprised to see DuckDB rise quite swiftly in this DB engines ranking. So at the moment, we're like at number 45 of the relational engines, which is something that I also didn't think was possible. And as you can see, we have now this wonderful sort of endless sort of mirror of this slide from past DuckCons, and I intend to continue this ad infinitum. Here's also something cool, like, again, people put especially VCs put way too much sort of thought into these star history sort of trackers, but I mean, we did have a celebration for the 10,000th star on GitHub, and we're already at like beyond 14 now, and that only seemed like it was very recent. Something I also find interesting is if you look at like Google Trends, you can kind of see, like in the last year or two, you can see this crazy increase in overall search traffic, and again, it matches up with what we see on our website visits. I also want to highlight some really cool things. So there's way too much in the DuckDB space out there for us to put on our website. But there is this wonderful list, Awesome DuckDB, in case you haven't seen it yet, that you can check out by David, where he kind of collects a bunch of interesting resources connected to DuckDB. And of course, you can send a pull request if you want to add your project. I also want to mention that today we have launched our new website, which looks much nicer. I want to say that there may be some of our so-called competitors that spend more time on their websites than we do, because we spend more time on making the system good as opposed to the website. However, it got to the point where people made fun of us for the website, so now we spend some time on it, and I want to thank Gabor for heading this effort. So thank you, Gabor, for the website. Also, people started writing books about DuckDB, which is also, I suppose the authors are here. So thank you for doing that. Mark and I did actually write a foreword for it. It's also an interesting experience to write a foreword. I've never done that before. But that's coming, so also something that we're just overwhelmed and excited about, that this is now happening. People write books about DuckDB. People build companies on DuckDB. So here's the the Times Square when Mother Duck got a Series B. This is, I think, the 3rd time the Duck has been on Times Square. So it's also something that to me seems quite surreal. And honestly, I still think these are photoshopped. But I have multiple angles from Times Square of this. So it must have been a big conspiracy. Okay, where are we going? I'm going to start with this, and I'm going to hand over to Mark for some more details on this. First, I want to talk a bit about the support policy of DuckDB. Maybe you've seen it. We wrote a blog post about this a couple of months ago. Basically, what we had to change a bit the way how we interacted with users on GitHub and Discord and so on, because many users means many questions, and we are not VC funded, which means we don't have 50 million sitting in a bank account that we can spend on a 50 people, DevRel team. We have one person on DevRel, which is again Gabor. You see, we kind of, everything important. Anyways, so we have to do some prioritization to support, to give like the best sort of outcome for the most people with the limited resources we have. And that means, like I'm listed here, I'm not going to go through the list, but basically means that we have to sort of choose a bit where we prioritize a support effort on. And so if you are on a big Indian PowerPC running, I don't know, Julia, we might not be able to, spend the same time on supporting your particular problem than we would be with a little more widespread sort of API. It's just like, if your issue is on Python on Windows, we probably have to deal with it, but and it will help more people than if we fix obscure problems and spend an enormous amount of time on. I do have one advertisement slide. Because we know that there's corporate users of DuckDB that depend quite heavily on DuckDB working, we do now offer support contracts from DuckDB Labs, from our commercial entity, that basically gets you privileged access to the DuckDB core team, where we promise you to work on your issues within a certain timeline, in private, with private data sets and so on. So you can just email us the DuckDB data file that you had issues with, and we can do that within one of these support contracts. And if you want to learn more about these, you can talk to me. Because we also don't have a giant sales team, we have Hannes. Okay, enough with the advertisement. I will now briefly talk about where we're going in terms of DuckDB. We are going to release DuckDB 0.10.0 in the next following week or two. The code name is already known. It's Fusca. It's another species of duck, of course. And then after that, we plan our 1.0 release, which for us is a big deal, in the first half of 2024. And we actually copied something from Apple, which is Snow Leopard. For those of you who are old enough to remember OS X Snow Leopard, it was an OS X release that had no new features, 0, but instead focused on getting everything sort of bulletproof. And we are going to try to do a Snow Duck, where we are going to release a series of bug fix releases, 0.10.1, 0.10.2, 0.2, and so on and so forth, with no new features, until we're kind of happy with the state of things, and then we're going to release that as the 1.0. And as I said, it will be focused on stability and robustness. We just want to make sure that this is a DuckDB release you can, deploy on a satellite and fly to Venus without having to worry about, patching your DuckDB instance halfway through. That's the idea. And the biggest, I think, and we think most exciting change from moving towards the 1.0 is that we're going to introduce a backwards compatibility of our database file format. And we think this is a big deal because it means that these database files will essentially be able to live forever. And we think we have a pretty interesting shot at becoming a new sort of de facto format to store tabular data in a somewhat efficient way with updates, multiple tables, the whole spiel. And Mark is going to tell you more about that. So with that, I will hand over to Mark.
All right.
And he will continue.
Thank you very much. Awesome. So first off, it's great to be here. Great to have all of you here. It's every DuckCon, it gets bigger and it keeps amazing me. It's fantastic. All right, so I'm going to do a bit of a talk on 0.10, where I will talk about all the new features, or at least a bit of a selected highlights of the new features. Like Hannes mentioned, one of the things that we are think is very cool that we're looking forward to is backwards compatibility. And kind of our surprise feature is that won't start with 1.0. It's actually going to start with 0.10. So one of the big things we wanted to do with 1.0, aside of the stability, the robustness of the system, is backwards compatibility. We kind of wanted to guarantee that a version, if you write a version 1.0 DuckDB database file, you can read it with version 1.1. You can read it with version 1.2, et cetera, et cetera. Similar to how SQLite works, for example. to make you actually trust the data format, right? To make it actually usable beyond for like short-lived stuff without having to do data migrations, without having to face all those pains, right? And we've been working on this quite hard. However, there's always one sort of caveat to having a stable storage format, and it's hard to actually extend and improve the format. And that to some extent runs counter to what we want to do, right? Because we don't want to be good enough. We want to be the best, right? We want to have the fast storage format that's highly compressible. We want to improve it. So that's kind of our design goal with our format, is to create a format where we can guarantee backwards compatibility so that any version of DuckDB can always read older database files. And we're going to do a best effort forwards compatibility, which means that if you're not using new features, you will be able to read a newer DuckDB file also with an older version, but it's not guaranteed. We're not guaranteeing you this. And we think this is kind of like a useful thing because it means that as long as you're running the latest DuckDB, you can read any DuckDB file that goes your way. If you can't read a DuckDB file, you can just update your DuckDB. Well, sometimes that's tough, but yeah, in the end, this allows us, I think, a good trade-off between having the latest features, the coolest stuff, while still being very stable. And like I mentioned, we're already going to do launch this as a sort of beta of backwards compatibility with v0.10. So v0.10 will be able to read files created by v0.92. So if you can see this like little bash shell I have here, you can see you can just create a DuckDB file with the current version of DuckDB, store some data in it, and with the latest version, you can just open it and you can query it, and everything should work as expected. And the idea is that we take this forward to 1.0, we take this forward to 1.1, etc., and ad infinitum to make the format actually like fully stable. v0.10 is also going to have partial forwards compatibility. And that's essentially that v0.92, it can read some of the files created by the new version. So if you can see here, if you just create a table and you store some like simple data in it, right? Like some integers, some character strings, it'll work, but it won't always work. There are some exceptions to this. So for example, we're introducing a new compression method in this release. The previous one won't have that, so it can't read files that use that compression method. We're also introducing some new types in this release, where I'll talk about some of those as well. And again, it won't work on the previous version if you're using those in your system, but there is partial forwards compatibility. All right. Another cool feature that I've written a blog post about recently, maybe some of you guys saw the blog post, is the attaching of multi-databases. So attaching, it's a feature that we actually have had for some time, but we have greatly expanded it. So when we first launched the attach commands, we could attach DuckDB database files and SQLite database files. And that worked very nicely. But it actually turns out that DuckDB has a very pluggable storage architecture that can be used way beyond just SQLite and DuckDB files. So one of the cool things you can do already, actually starting with v0.92, because I backported the extensions, is you can attach now Postgres and MySQL databases. So if you have a running Postgres instance, you can connect to it and you can run queries against them as if they're DuckDB tables. And you can do all sorts of cool stuff. You can do you can insert into those tables, you can read them out. You can also do copy statements. So you can take a Postgres table, copy it over to a Parquet file, or you can connect both in a MySQL instance and a Postgres instance and copy data between those two, right? You can use DuckDB as a bridge between MySQL and Postgres, for example. But it doesn't start at just ingesting data. You can do anything you can do in DuckDB. So it supports all the transactions. It supports deletes, updates. You can alter tables. All of that sort of stuff you can do with these new connectors. And this you can already use in the latest DuckDB version. And here's like a little code snippet. You basically just provide a type to your attach commands together with your connection string, and they can just query them as if they're normal tables. One of the other cool features has been worked on by Pedro from our team is we're launching a really big CSV reader overhaul in v0.10. And there's going to be I think the biggest selling point of this is going to be a giant performance improvement in CSV reading, including for just data ingestion. It's going to have better parallelism, and we're going to have very fast projection pushdown. So you can see here is the performance of reading some CSV files. This is a 800 megabyte file. You can see that the performance has sped up by around 3x on a MacBook. And on a 8 gigabyte file, it's gone up by around 2.5x. So there's like tons of performance improvements in the new CSV reader. And there's also a lot of small improvements. For example, we're doing much better error reporting, fixing a lot of bugs around different options that are being combined. So it's like, looking very cool, very nice work by Pedro. Another feature that's been worked on by Max from our team is fixed length arrays. So DuckDB, for those that haven't interfaced with it much, it has very powerful support for nested types that's also very fast. But previously, we only had like lists that could take on any width. However, for some use cases, like for example, in vector systems, you may often have vectors that have exactly the same width for every element. For example, you may have a 3-element vector. And this is now natively supported in DuckDB by using this syntax. Essentially, you can just create a list type, and then you can put between the brackets the width of your array, and then every single array must have the same width. And this is very cool because it saves on some storage space, some compute, right? Because you know every single list the same size. However, there's also a bunch of new array functions that you can use to operate on those, like the cross product, the dot product, the cosine similarity, and much more. That's going to launch in the next one. You can look at the documentation for more information if you're looking to use this type. Another cool feature that DuckDB has in general is its support for larger than memory operators, right? So DuckDB, it doesn't just require your data to fit in memory, it allows you to operate on tables that are much bigger than your RAM. And we're always working on extending that support. So in the previous release, we've launched out-of-core aggregates, which means we can process aggregates that have more groups than fit in your memory. And in this release, we're taking that one step further and launching a unified memory manager for the whole system. And essentially, this addresses a shortcoming of the previous DuckDB version where operators could go out of core, they could process large memory datasets, but they did not communicate between themselves. And this could run into issues when you're running like very complex queries that have like a bunch of joins, a bunch of aggregates, because each of those operators would still try to consume too much memory. With the new version, we're going to have a unified memory manager that allows all the operators to communicate their memory usage to one another. And that is going to mean that it's going to be way improved memory utilization for complex queries, which means you can now also run way more complex queries on way larger datasets without facing any out-of-memory issues. Another cool feature introduced by some of our team is the secret manager. So DuckDB has very good support for connecting to external blob stores like S3, like Azure. However, the secrets, they have been kind of implemented as this sort of setting thing, right? We have settings in DuckDB. The secrets were kind of piggybacking off of that. That's somewhat problematic because in one sense, it's limited. You could only have one secret for S3 instead of having multiple that are scoped. In the other sense, it's also not as nice because those secrets, they weren't designed to be secure necessarily. They're just sitting there. You could read them out. With v0.10, we're introducing a secret manager that allows you to create secrets with a native create secret syntax. And this also introduces a bunch of new features for managing secrets. For example, they can be scoped, so you can use multiple S3 secrets for different scopes. And they can also be persisted, so you can create secrets only once. And then whenever you launch DuckDB and want to read from S3, you can reuse those, so you don't need to set them every single time. Another cool feature that has been actually contributed by some research from the CWI, Azim, Leonardo, and Peter, is the ELP floating point compression. So we're always working on improving the compression of our file format. And previously, we had implemented actually a novel floating point compression called PATAS, which was based on chimp from the research literature. But the research at CWI actually invented a new floating point compression algorithm called ALP. And they have been so kind to contribute this upstream to DuckDB. And starting from the next release, this will be used out of the box to compress any floating point numbers or doubles that you store in DuckDB. And you can see here some of the performance of ELP compared to the previous compression algorithm, PATAS. You can see that not only does it achieve a smaller size footprint, the loading time has been reduced, the compression time, and the query footprint has been greatly reduced. So you can expect to see much better performance, compression ratio, and loading time floating points in the next release. We're also, of course, in the run-up to stabilizing our storage format, we have been wanting to do more work there. So we have been working on defragmentation a bit, and specifically on vacuuming of deleted tuples. So in previous versions of DuckDB, we would never vacuum any deleted tuples. That is now changed. We now have support for partial merging of row groups, which removes deleted tuples from the data during a checkpoint of a store table. This allows you to free up space here on disk file that can then be reused by new tables, and also speeds up subsequent queries because you're no longer having to always scan those deleted tuples. It's automatically done during the checkpoint. Also, the checkpoint is now multi-threaded, so all this happens in parallel as well. Finally, we have a bunch of CLI improvements. So I've been working on this a bit. We now have improved multi-line editing, and it's now the default mode. So if you're using the CLI, you can now have some more fun with bigger queries. And I've also improved faster text rendering because, after all, if you're going to DuckDB should be the fastest in everything, including text rendering. Why not? Then I want to give like a very brief overview of what we're planning to do going forward. Hannes already talked about the 1.0. That's going to be our Snow Duck, our stable DuckDB version. But of course, development doesn't stop there. We're always wanting to push the boundaries of what you can do in a data management system. One of the things that we're super excited about is extensions, as you have, like a lot of the stuff that I presented today has actually been shipped as part of extensions. And we kind of want to create a bigger extension ecosystem. So we're going to work towards making it possible to write extensions in maybe different languages. So we're thinking about allowing people to write extensions in Rust or Go, so they don't necessarily have to be tied to C++. We're also thinking about how we can deal with extensions made by third-party contributors and how we can sign them and get them distributed. We're always looking to make DuckDB faster, of course, so optimizer improvements. This is a long tail sort of thing. There's tons of cool stuff to do here. One of the things that I want to call out that we want to work on is the partition and sorting awareness. So currently, DuckDB just chunks through numbers crazy fast, but there's always more. It's always better to not do work than to do work, right? And if you make the system partition and sorting awareness aware, that can be a great boon to the performance. So that's something we're working on as well. We're also working on improving cardinality estimation and things around join order to make the system faster on smaller queries. Finally, lakehouse data formats is something that is very exciting, up and coming. We already have support for Iceberg, for reading Iceberg, but we want to extend this, particularly together with our pluggable database systems, to make this much more useful. And this, of course, ties into the partitioning and sorting awareness a bit as well. Cool. So thank you very much. Let's do the Q&A now. We have 5 minutes. I don't think we actually have 5 minutes, but Gabor has graciously given us 5 minutes. So please, if you want to ask any questions, now is the time. Or in the break. Or any time.